INSEAD. This is our latest tech talk. My name is Professor Jason Davis. I'm an entrepreneurship professor here studying digital innovation. I teach a course on crypto entrepreneurship, which has been my passion lately, and I do research on these topics. You can read more about me, or you can see the live stream for this event if you link up to my Twitter, Jason Davis, Big Tech Prof. We are excited to have Vitalik Buterin here, the co-founder of Ethereum. But before I introduce Vitalik, I'd like to thank some very important folks. First of all, the Ethereum Foundation and Ethereum SG, as well as the organizers, Digital at INSEAD, for helping us put this together. Like crypto, INSEAD is a decentralized place, and we've had great help from many people, including our student crypto organization, which is called the Savvy Salamander Study Club. They have their own NFT. If you're interested to check it out, please do. You can access them online. And we also have other interesting projects in crypto, for example, NFTs that we're developing as part of our mission to promote public goods. So finally, we'd like to thank Shanting and Freya, who worked nonstop actually to make this event work. So thanks for that. And now I suspect I probably don't need to introduce Vitalik very much, but let me at least say he is the co-founder and inventor of Ethereum, a decentralized smart contract platform and world computer, which runs many of the most prominent decentralized applications in finance, gaming, NFTs, and many other things. Vitalik is a technologist, philanthropist, and public intellectual who likes to comment on all sorts of issues, ranging from crypto regulation, Verkle trees, 1.5 dimensional chess, even unicorns sometimes. So all sorts of interesting topics. He's the continuing leader, I think, of the Ethereum community, and recently guided Ethereum through the Merge process, which I think many of you know about, and he'll tell us more about today. He's also a world traveler, spent time working with the Ethereum community in many places, including Singapore. So we wanted to welcome Vitalik back to Singapore. If the hints on Twitter are any guide, Vitalik has a very interesting presentation today about the future of Ethereum and what's going to happen there. Once he gives the talk, we'll also have some time for some Q&A that I'll lead as well before he needs to take off. So please join me now in welcoming Vitalik Buterin to INSEAD.
Okay, great. Here. Okay. Back. How do I go back? That's fine. Great. So I think. So first of all, I think this year has been a very exciting year for the Ethereum protocol, right? And probably the biggest thing that's happened is obviously the merge, right? And the merge is probably the single largest protocol change that the Ethereum network has ever had, right? So the merge is this the switch from proof of work to proof of stake. It's a project that has taken the Ethereum ecosystem somewhere close to about 8 years, right? So so the switch to proof of stake actually started with a blog post on Slasher, this very early kind of set of ideas around a proof of stake algorithm that we published in January 2014. So that post was actually published about 10 days before the Ethereum was kind of formally announced at that event at Bitcoin Miami. So at the time, proof of stake was still introduced as this very speculative idea, right? The tone of the blog post was basically, hey, we're researching proof of stake and we definitely don't want to promise that we're going to switch to proof of stake eventually, but we think that it has promise. And if we end up switching to proof of stake at some point, here are like some ideas that we might consider, right? And then since then, the work on proof of stake in Ethereum has become more and more concrete over time. So there was this blog post in November 2014 on weak subjectivity, which has been really important for kind of solidifying some of the philosophical ideas around proof of stake, something called nothing at stake attacks that a lot of people were very worried about, and that was cited as like a reason why proof of stake is impossible. And we figured out like what kinds of trade-offs we need to make proof of stake chains actually happen. And then 2015, 2016, like very early versions of the kind of proof of stake that we wanted to have were attempted. There were a lot of computer simulations. There were a lot of papers. There was this idea called consensus by bet. Then in 2017, something called Casper FFG was released. This was a paper with myself and a few other people that was basically incorporating some ideas from traditional consensus theory and trying to really figure out like how to make it work in a proof of stake blockchain context. And that's when like the design really started and kicked into full gear, right? So in 2018, started the development of the Beacon chain. Then in 2020, the Beacon chain launched. So the Beacon chain is the kind of formal and technical name for Ethereum's proof of stake chain, right? It's even though we merged to proof of stake only about 1.5 months ago, the Beacon chain has actually been running as a proof of stake chain for almost the last 2 years, right? It actually launched in December 2020. I was actually here in Singapore for like about half a year while that was all happening. So the proof of stake chain has been basically running for 2 years, right? And this was kind of like a half testnet, half mainnet phase. The idea being to make sure that the network actually works, give people time to adjust, give people time to run nodes, give people time to build up all of the infrastructure. We did Altair, which is like a hard fork that was really just there to prove that we could upgrade the system in 2021. And once we were sure that we could do it, then we finally did this big step of kind of moving the entire Ethereum system over from its proof of work chain onto the proof of stake chain, which is the merge, which is what happened about 1.5 months ago, right? So just quick kind of overview, what are proof of work and what are proof of stake, right? So blockchains are decentralized systems. They're there to basically allow communities to agree on stuff and to let people submit things that are called transactions that are just like globs of data that represent things that users want to do, and to agree on the order in which transactions appeared and what effects those transactions had, right? So the problem is in a decentralized system like this, you need to have this kind of public agreement, but you want to avoid like basically attackers, right? Like in a completely open system, one of the problems you have to face is like people trying to attack you, right? Like this happens everywhere. Like even on Twitter, you like often you just get like 500 bot accounts that are just like sending 500 fake messages and just like making it look like an entire community is piling on a person when in reality it's like just one bot, right? So blockchains like basically have a version of the same problem. It's called the Sybil attack problem, right? Like one attacker basically making a bunch of bots and pretending to be 1 million people. And because of the kind of philosophy of blockchains is to be fully open, fully permissionless. So like it can't sort of piggyback off of any permissioned identity system that exists in the existing world. The only way in which you can kind of solve the Sybil problem is by kind of limiting who can participate economically, right? So the way proof of work worked is that you have to have this very powerful computer called a miner. This miner would run 24/7, do a bunch of computations, and basically the only purpose of doing these computations 24/7 is just to prove that you have the big computer, right? And it's like, okay, if you have the big computer, then you're allowed to participate and you get to make blocks from time to time. And the purpose of running the computer 24/7 is to just prove that you have the computer. These computers are expensive, and like an attacker can't just like go and simulate 1 million of them. The only way the attacker could do that is if they have more economic resources than the rest of the network put together, right? So proof of work does this, and Bitcoin has been running on proof of work for more than 13 years. Ethereum ran on it for more than 7 years, and it's simple. It worked. At the very beginning, it was even very democratic because like anyone with just a regular laptop could go and like do this process called mining, where they would just run this program just on their laptop or desktop, regular computer. And once in a while, they would get Bitcoins, and then they get like a block reward of 50 Bitcoins. And there was like a fairly democratic way to distribute the supply, right? And Ethereum benefited from the same thing. But the problem with mining is like over time, it becomes more professionalized, it becomes more specialized, it becomes more of this like thing where basically only a fairly small number of rich people can participate. And it's just this big thing that's gobbling up huge amounts of electricity, right? Because like proof of work is about people proving that they have computers by running computations on those computers 24/7. This was in the case of Bitcoin, I think at least, I'm not sure what it's at now, but like at times it was spending more electricity than all of Singapore. And Ethereum was smaller, and it was like I think maybe somewhere between like 3 and 4 times smaller when it was a proof of work network. But these things burn a lot of electricity, right? And what proof of stake does is it basically says, instead of solving the Sybil attack problem by requiring a kind of like basically by measuring kind of participation by how much computing power you have, it measures participation by how many virtual assets you're kind of locking up and signing your transactions with, right? So in proof of work, you have $1,000, you use the $1,000 to buy a computer, then you prove that you have the computer by running it, and you can generate blocks, right? In proof of stake, you have $1,000, you use that $1,000 to buy ETH, and then you put that ETH into the proof of stake system, and you gain the right to create blocks once in a while, and that ETH deposited inside the proof of stake system essentially sort of acts as a virtual miner, right? So it's also doing this kind of economic resource-based design to prevent people from like basically pretending to have 1 million nodes if they don't actually like if they're only just one attacker. But it's doing it in this kind of virtualized way, which ensures that like it gets around this problem where like you don't anymore need to spend huge amounts of physical resources keeping the chain running, right? So the result is that the Ethereum network's energy consumption decreased by 99.95%, a factor of about 2,000. The proof of stake design also gave us an opportunity to really add a bunch of other really interesting security features, right? So like one example of this is, so like who here has deposited cryptocurrency into an exchange or used it to pay for things before? Okay, like, so who here remembers the experience of like waiting for 6 confirmations or waiting for 20 confirmations? Right, like it's a thing, right? Like, you deposit and then you have to like wait a bunch and then it's like, oh, okay, finally, you're good, right? Now, why does this mechanism exist, right? Basically, it exists because these proof of work as it was done so far is a chain-based system, right? It's like you have one block, then one block, then one block, then one block. And it's like a kind of real-time voting on what the chain, on the process of extending the chain, right? So the problem is, well, what if you send a transaction, that transaction gets included in one block, but then the 2 miners that make blocks right after them, they're both bad guys, right? They make 2 blocks, but those 2 blocks do not build on the block that appeared before that includes your transaction. They build on top of a different block. And so they make a different chain. That chain is longer than the chain that contains your transaction. And so your transaction went from being part of the chain to not being part of the chain, right? So to make sure that that's not going to happen, what exchanges and payment processors and all these people do is they wait until your transaction gets included in a block, and then some number of other blocks come in after it, right? And this is like what the number of confirmations means. And they have to do that because it's like the voting is sort of being done in series, right? It's like every block is one vote. And you just have to wait until there is enough that you can be sure that the probability that there is going to be an attacker is like exponentially tiny. Now, in our proof of stake design, what we instead have is we have parallel confirmations. As soon as a block gets published, thousands of people are voting on that block in parallel. And after only about a few seconds, like literally like 2 to 5 seconds, you get thousands of signatures that are supporting that block. And so you get thousands of signatures that are all kind of votes that are supporting it. And this basically makes it impossible for like any other block to kind of beat out that block, even if you have a couple, even if you have like 5 or 10 bad guys in a row, right? So that's the another kind of interesting side benefit of the proof of stake switch, right? Now, you could make a version of proof of work that has this kind of parallel voting. A lot of people actually tried. There are a lot of really interesting and fascinating designs. Though it actually is harder in proof of stake, it is easier, but proof of stake was also an opportunity for us to kind of make the consensus more sophisticated in a whole bunch of ways, right? So proof of stake has had some like really important benefits, and I think it's also really showed how the Ethereum ecosystem and community can kind of evolve and actually upgrade the system. And after this, there is going to be a bunch of these, a bunch of other challenges that we've been really talking about for a long time, right? So lots of people have been talking about scalability. Lots of people have been talking about user experience. Lots of people have been talking about privacy. Lots of people have been talking about, improving like speed of transaction confirmations, like all of these other problems that people have been like really talking about and have understood are problems for a while. But so far, the attention of developers has really been focused on the merge. And after the merge, we actually get an opportunity to like really fully refocus development effort on solving those things. And so I expect progress on those issues to like actually start happening very quickly, right? So I guess like first, why I think it is important to be kind of the technologies that are going to improve Ethereum and I think other blockchains too over the next 5 to 10 years, like why it's very important, right? Basically, I think it's easy to underappreciate the extent to which, like basically a huge, most of the reason why lots of blockchain applications have failed so far to the extent that they have failed, or to the extent that they haven't succeeded even more, is because of these technological limits, right? So to give one example, like let's say crypto payments, right? So you have payments online, you have payments in person, like over the last 10 years, many times, like whenever someone has offered the opportunity to like pay for coffee in Bitcoin or Ether or Zcash, I think I've used all three. Like I took that opportunity. I mean, I do like green tea instead of coffee, but like, coffee is like a metaphor, right? So it's, so whenever I tried paying for, metaphorical coffee with actual metaphorical gold, basically, it's interesting to see just like the kinds of problems that there were, right? So like what would happen is I would go in and, be in a store or a restaurant or whatever, and I would get the bill. And then to pay the bill, I'd have to scan the QR code. And then fortunately, like that would automatically kind of fill, or no, I'd have to open my wallet, then scan the QR code from inside the wallet. And then that would fill in the payment information. And then I'd have to click to send the transaction. And this is where the first problem comes, right? Like it turns out that, well, it's actually pretty obvious, right? That in a kind of in-person consumer merchant payment context, the merchant's internet is going to be reliable because like they're the merchant and, they have internet, it's their place. The consumer's internet is often not reliable, right? Like when you're going indoors, like, buildings are made out of stuff. And sometimes that stuff interferes with cell signals. And sometimes that interference is worse than other places. Sometimes cell signals are just like not perfect even without the interference, right? Like like even today, like literally even in Singapore, like just like one random example of this is like I was just going on a run a couple of days ago, and the GPS just like randomly teleported a few hundred meters in the middle of the run a couple of times. And it's like, what? How did this guy run a kilometer in 18 seconds? Like, no. My GPS location made me teleport, see? So, like, sometimes, internet connectivity just like it disappears for 30 seconds. And like, this stuff happens. This stuff happens even in advanced countries, right? And so, well, okay, what happens if you're a consumer, your internet's unreliable and you're paying the bill? Well, okay, you click send. What's going on? What's going on? Okay, solve the internet problem, right? Then what happens? Then finally we get to the crypto-y part, right? Because like what I've said so far, like that actually applies even to centralized in-person payments. Now we get to the crypto-y part. Send the transaction to the blockchain, and at first, the transaction is kind of floating in what's called the mempool, right? The mempool is like the set of transactions that have not yet been included in blocks. Now, the time between blocks on a blockchain. In Ethereum, it's 12 seconds. It used to be 13 seconds. Actually, the merge significantly improved this. This is actually this kind of like really interesting math riddle, right? It's so proof of work and proof of stake, they both have on average about the same block time, right? So right now it's 12, before it was 13, but like let's just say it was 12 and 12. But here, so the riddle is this. In proof of work, when you send a transaction, on average, you would have to wait 12 seconds until the next block comes. In proof of stake, on average, you have to wait 6, right? Which is weird, right? It's like, in both cases, the time between blocks on average is 12. But in one, on average, you wait 6. On the other, on average, you wait 12. Well, it turns out that there's this interesting difference between what's called a Poisson distribution, which is what proof of work does, where there is like basically a 1/12 chance a block appears every second, versus what proof of stake does, where like blocks appear like clockwork, like basically one block exactly every 12 seconds, because that's how the system assigns it. And proof of stake actually like gives you the 6 second average wait instead of the 12. And then if you look at like the worst case wait, well, in proof of work, the worst case is like, well, sometimes you have 40 seconds between blocks, sometimes you have 60, sometimes you have 80. And in proof of stake, like, okay, usually it's 12. And sometimes like when a proposer is missing, which occasionally happens, like 1 or 2% of the time it's 24. And then like, 0.01% of the time it's 36, right? And so that's one problem, right? Like 12 seconds is already a long time. 40 seconds is a longer time. Another problem is that when you send a transaction, then it does not necessarily get into the next block, right? There is this concept of a fee market, and like your transaction has to include what fee it's supposed to pay. And sometimes like if you don't set your fee high enough, then your transaction doesn't get included because everyone else pays higher fees. And then sometimes you accidentally set your fee too low and you end up having to wait. Sometimes you get in 20 seconds. Sometimes you have to wait like 5 minutes. Sometimes you have to wait like an hour, right? Now, 2 years ago, we added something called EIP 1559, which modifies the fee market design so that instead of blocks always being full, blocks are on average half full, and there's like a floating fee mechanism. So that actually made it significantly easier for transactions to get in. And like, we got a lot of user feedback that this was really noticeable, right? Like users really noticed that like, wait, before this change, sometimes I'd wait like 20 seconds, sometimes I'd wait 5 minutes. After this change, like, oh, stuff actually reliably gets in within 30 to 60 seconds now. And then after the merge, oh, stuff reliably gets in within like 6 to 30 seconds now, right? So so that issue, right? Like it's improved a lot, but like it's still not quite there yet, right? So then, okay, so that's the next issue. Then the third issue is the fees, right? So even if you send your transaction, it gets in fairly quickly, and all of those things happen fairly quickly. Well, last year, the fees to send a transaction on the Ethereum network were like somewhere over $5, right? And this is just like a regular send, just like sending someone ETH. If you want to send an ERC20, it's double that. If you want to do a Uniswap trade, it's like 6 times that. If you want to do anything privacy preserving, it's like 30 times that, right? So, what's going on, right? Basically, yeah, the whole like movements to try to use blockchains and cryptocurrency for in-person payments, like this was a really big thing that lots of people were enthusiastically pushing, even back in 2013 and 2014, right? And when they were pushing this, it's back then, one of the common arguments that for using cryptocurrency was like, hey, look, the credit card companies and PayPal, they're really screwing you over. Like, they have fees of like 2.9% plus 29 cents a transaction. And then if it's international, they add like just like really horrible exchange rates, and like it's like an extra 4% on top, and it's just crazy, right? And then here you have cryptocurrency, and ding, and like the fee is less than 1 cent. Well, that argument just like completely broke because we did not solve the scalability problem in time. And so by the time 2017 came around, like on Bitcoin, fees went up to about $50. And then back then, ETH was still cheap, or sorry, the transaction fees on Ethereum was still cheap. But then in 2021, even the transaction fees on Ethereum were not cheap, right? And that just like in-person payments in that context just like doesn't work anymore. It's like, okay, have your metaphorical coffee. That'll be, maybe like $4.49 for the coffee, and then add another $5.15 for the blockchain fee. Amazing. Yeah, I know. Great next generation system you got there, right? So, the point is that like and then we can then start talking about privacy, which is an important topic. And like right now, basically, so Zuko, the founder of Zcash, a cryptocurrency based on some fancy cryptographic technologies to improve on privacy, he has this kind of motto that like existing cryptocurrency is like Twitter for your bank account, right? It's like, every time you buy your metaphorical coffee, it's like, oh, here's the payment. Anyone can go and see it. And anyone can run fancy AI analysis algorithms and like, see like, oh, try to like tie your different accounts to a particular identity. And they can see like, oh, here's this payment. And like at that time, that amount of ETH was worth $13.89. And that payment looks like it was going to a pharmacy. What product at a pharmacy costs $13.89? Well, we can look and check, right? So, like the current state of privacy on chain sucks. And this is something that does deter definitely individuals. It also really deters enterprise users, right? Because, enterprise users, like they both kind of can afford to think about privacy issues more deeply, but also like they just have to, right? Like if any of their, users has some privacy issues because of something they did, then, like that turns into a complaint, that turns into a risk, and that kind of bubbles up, right? And, even for enterprise users, like, lack of privacy is a big deal, right? So scalability issues, user experience issues, privacy issues, security issues, right? The possibility that like, if your private key disappears, then, or like if you lose your phone, then, and your private key is on your phone, and then like you might lose $100,000, or if someone steals your phone, or if you make a backup, then you have to also worry about someone stealing your backup. If they steal either of those things, then they steal your $100,000. So like, there's just all of these issues that are like still a big deal today. And on the one hand, that's bad news for people building things today, right? But on the other hand, the other way in which I look at it is that that's kind of good news. And the way in which it's good news is that it still shows how much further we have, like how much higher, further we can go, right? Like if we look at how much adoption, how much interest, how much of everything blockchains and Web3 and crypto and all of these things have had today, imagine what that's going to look like when transaction fees are 1 cent, privacy issues are solved, and everyone can, use their blockchain and Web3 application, peacefully and safely, and knowing that there's good solutions to protect against loss and theft, right? So this is like the stuff that I think the Ethereum community is really enthusiastically going after, and there's like a pretty detailed roadmap for really going after all of these issues over the next 5 to 10 years. Now, actually, so one of the things that I wanted to kind of zoom in on today, right, is ZK technology, ZK snarks in particular. So, and I'm gonna have some metaphorical milk. Okay, wait, that's, I mean, cows output milk, they don't input it, but you know what I mean. Okay. Okay, now the metaphorical milk is sliding. Okay, here. So ZK snarks, right? So I actually, I fully expect ZK snarks to be as important as blockchains in the next 10 years, right? This is one of the things that I think is really worth being on people's radar. And it's like a really huge and powerful technology that has been kind of just getting more and more use and more adoption over the last few years, right? So one of the kind of highly technical analogies that I use sometimes to talk about this is that, like, if you look, think about what's happened in the AI space in the last 10 years, right? Like, if you remember what AI was like 10 years ago, AI 10 years ago was like this very specialized thing. Every time you wanted to have like a different application or you wanted to solve a different problem, you needed to make something that's like really specialized to that problem. Like, you needed to have like humans go in and spend a lot of effort on like designing features. You needed to have a different design if you're making an AI to recognize what's a cat and what's a dog, and a different AI to play chess, a different AI to play Go. There was a lot of hard coding in the chess and the Go AIs. It was like very sort of application specific. There was like specific solution, had to tailor it to every single problem. What do we have now? Like, just use a transformer, right? Just like have a problem, put a transformer on it. Have a problem, put a transformer on it. And like the more the technology improved, the more we're at the stage where like you just have like a very small number of tools, and you just use those exact same tools to whack every single problem. And it turns out that it just like works even better than human fine-tuning, right? And I think AI is one of the technologies whose progress has like really impressed people in the last few years, right? Like, you know, at the same time as like, you know, stuff in Bitcoin land and stuff in Ethereum and like, you know, getting to the merge and getting to the Lightning Network and rollups and all of these things have been slower than people have expected. Like AI has been faster than people have expected. What's the one thing in the crypto space that has gone faster than people have expected? I would actually, technologically speaking, I would say it is zk-SNARK research, right? So zk-SNARKs are basically that same thing as I was talking about to AI happening to crypto. They are this really powerful general purpose hammer that can basically be used to solve half of every problem. Now, what is a zk-SNARK, right? Basically, a zk-SNARK is a cryptographic proof that lets you prove that that you made a computation with some data. You can reveal some of the data, and you cannot reveal other parts of that data. And that computation had a particular result. And the zk-SNARK is just like a proof that you generate locally, but then someone else can. The proof is very small, and someone else can verify very quickly that proves that that computation had a particular the result that you computed, and they don't have to do the computation themselves, right? So, like for example, today the way blockchains work is if you run a node as part of the network, then you verify each block by basically rerunning all of the transactions yourself, right? This is how it works in Bitcoin. This is how it works in Ethereum. This is how it works in like basically every real blockchain, right? What will you be able to do with zk-SNARKs? Well, the one person who creates the block, they will also generate a zk-SNARK, which proves what the result of processing that block is. And then they publish that block along with the proof. And everyone else, instead of just running the entire block themselves, they just verify the proof and they know that the block is correct, right? So it's a very powerful hammer for scalability problems, and it's also a very powerful hammer for privacy problems. Basically, because zk-SNARKs have this capability that you can prove things over data, even when some of that data is being kept private. So this is already used in a bunch of cryptocurrency contexts. So like Zcash is the kind of big flagship cryptocurrency of privacy in a lot of ways. And you know, Zcash uses zk-SNARKs, and it uses them to preserve privacy of payments. Then, you know, there's a lot, increasingly in the Ethereum space, a lot of non-financial applications, and I'm going to talk about some of them. And you know, in the scaling space, there's like these zk rollups, which are these layer 2 projects that are basically using zk-SNARKs to kind of create these much more scalable but still secure second layer systems on top of Ethereum even today, right? So about 4 years ago, I think protocol design was this like very application specific thing where like for specific problems, you had specific solutions and you had to like really tailor the infrastructure to deal with specific problems, right? And then these days it's getting closer and closer to you have a problem, just nuke it with a zk-SNARK, right? So it's getting, in some ways, you know, even as the implementations can be complex, like conceptually stuff is starting to get simpler, which I think is something really fascinating, right? So ZK's SNARKs for scaling, right? They're very important. So today, this work is happening on layer 2s, right? So layer 2s are protocols that sit on top of blockchains like Ethereum and that inherit security from blockchains like Ethereum, but that also add extra features, in this case, more scalability on top, right? So they only use blockchains a little bit. They use blockchains just the minimum enough that they need to use them in order to be as secure as they can be. But a huge amount of the actual work in the computation is being done off-chain, right? So ZK rollups basically use zk-SNARKs, and they're kind of like mini Ethereums inside of an Ethereum, right? So if like I have some ETH and I want to move it inside of one of these ZK rollups, I would send my ETH to the smart contract that runs the ZK rollup system. And then from the point of view of Ethereum, that ETH is now owned by that smart contract. But the ZK rollup also has its own internal point of view, right? And the ZK rollup has its own internal account system, and I have an internal account inside of that ZK rollup, and I'd be able to do my kind of Ethereum equivalent stuff inside of that ZK rollup. And then when the time comes to withdraw, I can make a withdrawal message, and that withdrawal message gets included. And then the smart contract like basically outputs a message that sends the ETH back to whatever address I want to withdraw it to, right? So the internal logic is simulating a system that is basically, it works and feels basically the same way that Ethereum itself does, but it's a system where it's much more scalable, and transaction costs are much lower, and it completely avoids most of the inefficiencies of doing everything on layer one. So ZK rollups are very powerful. Validiums are like this interesting kind of hybrid compromise option where they do even less stuff on chain and they do even more stuff on off chain. And so Validiums have even lower fees today. But the compromise is like you do have a little bit of trust in that you have to trust the operator of the Validium not to disappear, right? So the operator of the Validium, they cannot do something wrong, right? But they can disappear. And so like they can't steal money, but they can make everyone's money go away. And so it's this, but the benefit is like basically fees go way down, right? And Starkware is experimenting a lot with both ZK rollups and Validiums. It's a really powerful model for them. For a lot of enterprise applications, I think Validiums make a huge amount of sense. Like basically, I would even say that like any enterprise application that people wanted to do on top of a private blockchain or a permission blockchain 5 years ago, it makes much more sense to just do it as a Validium on top of Ethereum. Like even if the Validium is run by one server, right? Like, I believe in pragmatic compromises between centralized and decentralized approaches, especially if you're trying to kind of incorporate legacy infrastructure. But I think like not all compromises are equal, and some compromises are just more technically sensible than others, right? And like I just think Validiums do actually make much more sense than permissioned chains, and more people should look into them. But this is all layer 2 stuff, right? The next kind of prize for scaling is, well, what can we do at layer 1, right? So basically, the dream is what I call like an Ethereum node in one proof, right? So today, if you're running a node in the Ethereum network and you want to verify that whenever you receive a block, you have to verify that block is correct. And well, how do you do that? Today, you just kind of re-execute everything, you store everything, you download everything, you process everything. Well, what if instead of doing that, you replace that computation with just a snark, right? So we can do it piece by piece. So we can replace just the EVM with a snark. We can replace what's called the consensus layer, so like the proof of stake part of the system with a snark. We can replace state access proofs. So this is like proofs that prove when a block is accessing particular accounts, kind of what was in that account before. You can replace that component with a proof. And then you can make 3 proofs, and you can make a 1 proof that says that all 3 of those proofs are valid. And then you have like an Ethereum node in 1 proof, right? So just verifying an Ethereum block an extremely rapid and seamless experience. So that's Snarks for scaling. Snarks for privacy, right? So this is the stuff that's happening at the application layer. And I think this decade is like a great decade to really think about blockchains from an application layer perspective, and like what are you going to actually build on top of them? Basically, because the underlying technology that enables doing what you need to do is like finally actually being solved, right? So a couple of interesting ones, financial applications. Obviously, financial privacy is important, and crypto started with finance. It's not just finance, but finance continues to be very important to people. Governance and voting, I'll talk about the need for privacy in that. Identity and reputation, a rapidly growing space within Ethereum, talk about the needs for privacy in that. And privacy for smart contracts, right? So financial applications. So this is like a basic design, and this is essentially the design that like every on-chain ZK Snark-based privacy solution uses so far, right? So Zcash uses it, a lot of all the stuff on Ethereum that's trying to achieve ZK Snark-based privacy uses it. It's all the same technology. So how does this work, right? Basically, the goal is that you need to prove, like, we need to achieve two properties at the same time. One property is when you're spending a coin, you have to prove that you actually have the coin, right? And you have to prove that you actually have a coin without pointing to exactly which coin you have, because that breaks privacy. The second thing is we have to prevent people from spending the same coin twice, right? So whenever you spend a coin, you have to reveal some piece of information where that piece of information prevents you from spending that same coin again, but you have to somehow do this without linking and kind of revealing the link to which particular coin you're spending, right? So it's a really fascinating mathematical puzzle. Here is just like an approximate diagram of like how this is solved, right? So just let's take a very simple example, right? Where there's only one denomination of coin. Let's say it's 1 ETH, right? So the only thing you can do is like you can send 1 ETH. And if you want to send people 5 ETH, well, yeah, you just have to like do this thing 5 times, right? So here's how it works. Every coin is defined by this kind of number called a secret. That secret is just stored by the user, right? Now, if you you can hash that secret in 2 ways, right? So if you hash it together with the number 1, then you get this value called a leaf. And then if you hash it together with the number 2, then you get this value called a nullifier. Now, if you see a leaf and a nullifier, you have no idea whether or not that leaf is connected to that nullifier, right? So like if I give you 100 leaves and 100 nullifiers, you will not be able to tell which leaf corresponds to which nullifier. But every leaf has exactly 1 corresponding nullifier, and only if you have a secret can you actually generate the leaf and the nullifier yourself, right? So it feels like we're starting to get closer to a solution, right? So basically, yeah, the leaf is like the public value of the coin. Leaves are published when the coin is created, and nullifiers are published when a coin is spent. Now, every leaf has only 1 corresponding nullifier, and so if you try to spend the same leaf twice, you're going to end up revealing the same nullifier twice, and so you're going to reveal that you tried to spend a coin twice. But if you only spend a coin once, and if everyone you have a bunch of people that are only trying to spend a coin once, then you're like, okay, you're revealing 100 leaves, you're revealing 100 nullifiers, and no one knows which leaf corresponds to which nullifier, right? So how does this work with ZK snarks? So when a coin gets created, you publish a leaf on chain, and that leaf goes into this object called a Merkle tree, right? And a Merkle tree is kind of this cryptographic structure where you take these leaves and you hash 2 leaves together, you hash 2 hashes together, you hash 2 hashes together, and you keep on kind of hashing things together until you just get like 1 root at the top, right? Now, then when you want to spend a coin, well, what do? You have to prove that you have, or you publish a nullifier, and then you prove that you have some secret where that secret creates that nullifier, and that secret creates some leaf that's in the tree. You don't reveal which leaf, right? So you use a snark, private information, you make a proof that that proves that the statement is correct, but does not reveal why the statement is correct. That just proves that you have a leaf somewhere in the tree, and that the nullifier that you're publishing is correct. You prove there's 2 things, and we have both our goals achieved, right? So you prove that you have a leaf in the tree, so you prove that you have a coin. And you publish the nullifier, you prove you publish the nullifier correctly. Nullifier prevents you from spending the same coin twice, because if you spend the same coin twice, you reveal the same nullifier twice, and the second time it gets rejected. And it's because you're not just like revealing the data, you're making a snark, you're actually making you're not actually revealing any information, right? So basically, this is like how privacy is revealed in a lot of these systems. So here is a newer kind of like really interesting thing, right? ZK proved that you're not a hacker. So here's the challenge, right? So like, let's say you have, like, this is stuff that has actually happened in the last few months, and it's interesting. I think it's an interesting case study to see how like the solution to the problem is basically just like even more ZK snark technology, right? So here's the problem, right? Like, let's say you have one of these privacy gadgets, a bunch of people put their money in. But then one of the people that puts money in is like someone that just like made some really big hack, right? So someone, stole $1 million from someone, or hacked a DeFi platform, or, just like did something obviously bad and stuck their money into the system. And they're basically trying to like anonymize it and make themselves look legit, right? So how could we, how could the rest of the users of the system stop them? Well, here's one thing that you can do. You can make a ZK snark that proves that not only did your coin come from this tree, but that your coin came from a smaller subset that does not include the hacker, right? So instead of like saying, either I'm one of these 100 people, you can say, I'm one of these 95 people, and I'm just gonna tell you like, these are the 5 people that I'm proving I'm not. Now, you're not revealing which one of the other 95 people you are, right? And you're not even giving like some regulator a backdoor key. There's no backdoors, you have privacy. It's like actually, very clean. It's still kind of very cypherpunk spirited in that way. But, you're proving that you're not a hacker. So this is, it's good for you because, you've proven you're not a hacker. And so like, if you try to deposit into an exchange, the exchange will be less suspicious of you. And you're also not contributing to the anonymity set of the hacker, right? So if, users start doing this by default, then okay, 100 people put their coins in and 5 of those people are a hacker, then the other 95 all prove that they're not a hacker. And then the hacker can't prove that they're not a hacker. So they try to take their coins out without a proof. And it's just obvious to everyone that like, hey, we don't know which one of the 5 hackers you are, but you're still one of the 5 hackers, right? So this is something that's kind of like a lot of people are sort of in the process of trying to figure out and build, but I think it's like it's a fascinating example of how this very clever use of ZK technology can kind of satisfy people's privacy objectives and security objectives and compliance objectives, and just like make lots of people happy at the same time. So so I think that's like an important general lesson to have. Governance and voting. So governance and voting is interesting because I think the case for privacy here is like even more obvious than the case for privacy in finance, right? Like votes in democratic systems are basically always done by secret ballots, right? Like when you vote, nobody sees how you voted. Like, even the government doesn't see how you voted, right? Like there isn't even, a mechanism where like someone can see how you voted to make sure that you're not voting for bad people. There might be countries where that happens, but, we generally call them not actually democratic, right? So in a democracy, like having total privacy of your vote is like always just accepted as a fundamental part of how the mechanism works, right? Because we want people to vote their actual opinions instead of being intimidated by someone into voting a particular way. In fact, we even want a very strong form of privacy called coercion resistance, right? Coercion resistance says you can't prove to a third party how you voted, even if he wants to prove that. Now, why do we want coercion resistance? Because we want to prevent people from selling their votes, right? Because if you can sell your vote, then whoever the richest person is will just buy up all the poor people's votes, and like they'll be able to just decide what policy is, right? Actually, something very similar to that even has happened within crypto projects on a couple of occasions, right? So what happens in crypto projects, right, is basically that people tried making these kind of coin voting systems where you have protocols and they want to have kind of community-driven governance, but the only way that they have of figuring out whether or not you're in the community is checking whether or not you have coins, right? And so what they do is they just do coin voting. They just say, oh, if you have coins, then you can vote, and the number of coins you have determines how many votes you can make. Now, what ends up happening is basically that like you actually have these services that kind of provide pools, and you put the coins into a pool, and then the pool might even give you benefits. Like they say, oh, we're a staking pool and we're going to stake for you, and we're going to give you back like 100 or 105 or whatever % of the staking rewards. But then what do? Well, they have your coins, and they can use your coins to vote, right? So it's this kind of, it's basically like literally into vote buying with just like one tiny layer of obfuscation, so that instead of like being called vote buying, it's called a staking pool, right? So like, if you sell your vote, you can kind of feel good, like, hey, you're not selling out, you're just like joining a staking pool, and it's lovely, and it's a pool, and we're all happy and together, and we're getting rewards. So like actually making any kind of governance that involves decentralized voting secure against coercion and secure against people selling their votes requires a strong form of privacy. Now, how can we do this? Well, ZK snarks, right? So there's this project called Macy that the Ethereum Foundation team and a couple of other people have been working on for a few years. Basically, it is a voting system, a blockchain-based voting system that's designed around providing these very strong forms of privacy, right? So basically, when you make your vote, you can encrypt your vote, and you encrypt your vote to this kind of key that's controlled by the tallying system. And that key itself can be kind of locked down in a bunch of ways. Like you could be put inside of trusted hardware, or could be put inside of an MPC. So you have like a bunch of people that work together to do the tallying. And then you publish your vote on chain, right? And the nice thing about publishing your vote on chain is that it makes it very obvious that the voting system is censorship resistant. Like they just can't ignore your vote, right? So you encrypt your vote, publish the vote on chain. Everyone publishes their votes on chain. Now, here's why you can't prove how you voted. Everyone has the right to publish another vote later to cancel their vote, right? So if, let's say, I want to vote for Alice, but then you, as a rich guy, want me to vote for Bob, and you pay me $5 to vote for Bob, here's what I do. I make one vote for Bob, and then I make a proof proving to you that I made a vote for Bob. When I'm done doing that, I also, or even before, I just quietly later make a different vote that votes for Alice. I have no way to prove to you that I did not do that, because all the votes are encrypted, like any of those other votes could be mine. So publish the votes, and then at the end, the system uses a ZK snark to basically provide the output and prove that the output actually is the result of taking everyone's votes into account. So very simple system. It's kind of still in the process of being improved. Something called CLR Fund, which is a quadratic funding platform. Quadratic funding is itself this like really fascinating rabbit hole. It's just basically, it's this form of kind of crowdfunding where projects also, like there also is this kind of central matching pool, but then the matching pool is allocated to projects in such a way that like basically the matching ratio is bigger the more distinct people contribute to a project, right? So like if you have 5 people that each contribute $1,000, like they get some matching amount, but if you have 5,000 people that each contribute $1, then like the project, the matching is much bigger, right? So it kind of intentionally tries to sort of like compensate for and give more power to the people and kind of prevent sort of disproportionate power from being in the hands of a very small number of rich people. So it uses basically Macy to also prevent these kinds of like buying and collusion issues from and like bribing and all this stuff from happening, right? So real life project, it's in development. You can go use CLR Fund. It's great, but still being improved. Identity and reputation is interesting, right? So I actually think identity is going to be one of the big kind of things happening in the Ethereum space pretty soon. And it's kind of one of the big things quietly happening already, right? Like, I think the problem with identity projects 5 years ago is that people tried to do identity as a platform. People tried to say, I am a company, I am going to provide identity. Oh, I bring you identity. Which is, not much better than like, oh, I am Mark Zuckerberg. I bring you money. I bring you metaverse. But like, basically, I think identity works much better when it's this kind of organic thing that emerges out of people's actual needs. And this is what we're actually starting to see happen in the Ethereum ecosystem, right? So like Ethereum identity projects, one, ENS, right? So like, if you want to have just like a short name that other people can use to, send you ETH or like send you digital monkeys or, like chat with you using a Web3 based chat application, you don't have to give them this long, complicated 40-character address. Like you can just tell them, hey, I'm Vitalik.eth or like I'm whatever.eth. And ENS is just a system that the decentralized system lives on chain that kind of maintains the mapping between, like Vitalik.eth or whatever your name is .eth and whatever address you're connected to. So ENS is one example. Sign in with Ethereum. This is something that's gotten bigger over the last year and a half or so. Basically, if you have an Ethereum account, you can use it to sign into things the same way that you can sign into things with a Google or Facebook account. There's more and more services that support this. So chat.blockscan.com. It's this kind of like encrypted chat application. It's like basically Telegram, but where it has actual encryption and where you sign in with Ethereum, right? So like one of the things I hate the most about Signal is the phone number dependence, right? Like if you have a Signal account, it depends on your phone number, and if you want to give some of your contact, you have to give them your phone number, and so now your phone number is in a bunch of places, and people can spam you with calls, and people know who to target if they want to SIM swap you and all of these terrible things, right? And also, like if something happens to your phone plan, then you're screwed, and like it just forces you into one particular centralized account model. So here, well, you can sign in with an Ethereum account. And the nice thing about Ethereum accounts is, well, they can be smart contracts, they can be regular accounts. You just have a lot of freedom in just like making your kind of policy for recovering your accounts just like be whatever you want. And it's this thing that purely you control. Like there's no dependency on a phone number company. There is no dependency on a particular identity system. Like it just is, what you want it to be, right? So, but then the nice thing about these things is that there's synergies between them, right? So like if you want to send me a message on chat.blockscan.com, then all you have to do is like in the recipient field, you type in Vitalik.eth, which is my ENS, right? And then when I log in, I appear on the platform as being Vitalik.eth, right? So I'm signing in with an Ethereum account, and it detects the fact that that Ethereum account has an ENS name attached. There's POPE, the proof of attendance protocol. This is another identity thing. It's basically, it is an NFT that you get. Basically, it's like a protocol for issuing NFTs that represent participating at particular events, right? So if I participate at some event, then often I can get a POPE at that event, right? Basically, so there's a POPE for a lot of meetups. There's a POPE for a lot of conferences. There's a POPE for a lot of online events. It's just like a generic protocol, and you can kind of accrue information about like what kinds of things you participated in that can then be used to kind of as a different and sort of less financialized way of proving that you actually are a member of some communities. Proof of Humanity, POH, is a DAO that basically tries to maintain a list of accounts that have been verified to correspond to unique humans, right? So lots of identity and reputation applications. They're very important for Ethereum, but what's the problem? We need privacy. Like we don't really actually want to, we don't necessarily want like Twitter for every meetup you visit, right? Like for, me personally, it might even be, an actual security risk. So like immediately broadcast, what my POPes are for every single thing that I do, right? So it's, look, we don't want everyone's information to be public by default, right? And how can we have identity and reputation systems and still be able to prove things about yourself while preserving privacy? Well, maybe there's a cryptographic technology for this, right? So, ZK Starks. Negative reputation is like a really fascinating one, right? Like you can even have negative reputation, which is interesting. You can prove that like you did not do things. You can prove that something did not happen to you. So this is like one really fun example. Suppose that you wanted to have an internet forum where people could post anonymously. So when you post, no one can see who posted, but you still have an account system. So like, you still have to kind of go through some process to register to get in. And like, it could be some cost that you have to pay. It could be, some ENS name. It could be a POPE. It could be whatever, right? But then so you use that to get in, and then you can make posts anonymously, but there's still a moderation system, right? And like, if you go against the moderation system too much, then like, you lose your account and you have to get another one. And the theory is that this makes it expensive to be, doing too much spam or too much bad stuff, right? So like, what if, you want to give people the benefits of, complete anonymity, but at the same time, still have like this level of moderation that you would not be able to have if you just, do complete anonymity the, kind of the naive way, right? So what do you do? Well, ZK Snarks, right? So basically, the idea is that every user would have this kind of like, basically have this kind of like chain of posts, and every post that they make would contain a ZK snark. And that ZK snark, in order for the post to be accepted, the ZK snark would have to contain a reference to the previous post and a reference to all the kind of moderation actions that happened on chain after the previous post, right? So in this little example I have in my slide, so you join, and let's say in this case you join with a proof of humanity profile, then you make your first post, and your first post just points to inclusion and it's just hello world. Then you make your second post and you decide to make some hate speech against blue-eyed people, and then moderation action violated one strike. And then your third post, well, guess what? Every post just is required by the rules of the system to have a ZK snark pointing to the previous post. It's a ZK snark, so you're not actually revealing that which post is connected to which other post. It's still kind of anonymous, but like, guess what? The rules of the system force you to take the moderation action into account, and so your account only has 2 strikes left, right? So moral of the story again, right, is like ZK snarks are like this powerful technology that can get you, lots of privacy and like lots of accountability and just like lots of like very good things at the same time in a way that I think people would probably would not have imagined would even be possible 10 or 15 years ago. So interesting, like smart contract privacy. This is the last one. This is actually probably one of the kind of negative examples that I have to give, right? So this is like something that's really hard to do or that you can't do. So the question is, well, can we just make an entire Ethereum that is private? And it turns out the answer is that, well, no, actually, no, it's quite hard. And it's hard for fundamental reasons, right? The way that ZK snarks work as a technology is that whoever makes a proof about a piece of information needs to see that information, right? So in order to make a proof about something that you have to know the thing. Now, for a reputation system, this works well because, well, who can be kind of the logical owner of all of the information about the reputation? Well, you can be. For a financial system, it makes sense because like who is the natural actor to kind of know everything about what coins you have? Well, it's you. For something like Uniswap, you cannot do this. Now, why can you not do this with Uniswap? Because Uniswap is fundamentally like, it's one kind of logically centralized monolithic thing, right? Like there is one central pool that everyone is interacting with. And so, look, who is, like, if you're going to try to encrypt it, like who's going to have that information? You basically need to have some central actor that has to be kind of like approving every trade. And then that central actor has, is going to see what all the trades are. And like the whole thing just doesn't make any sense. And like, well, in order for it to actually make sense, you have to redesign the whole thing and turn it into an order book, right? So there is like, basically, the EVM is not really designed around this idea that the accounts and like state are split up into objects where every object has an owner. And to some extent, that's like the power of the system. But it also means that like it's hard for it to like really interact with privacy enhancing mechanisms. And so if we want to have privacy for smart contracts, we're going to have to create new systems that don't entirely work like the EVM, that sort of have their own logic inside of them, right? And there's a lot of great projects like Aztec that are actually making a lot of great progress on this, right? So future of ZK snark privacy, I think making things easier for developers. If people are developers here, there's lots of great tools to start, but those tools can be made even better. Improve efficiency. Like we basically need to get efficiency to the point where it's just practical for every single user operation to carry a snark, right? So, if we can get to the point where, like, for example, someone can make a version of Twitter where like every single like and retweet has a ZK snark attached, right? Like we're not at that level where things are seamless yet. We're still at the level where like your phone has to work hard for a few seconds. We need to get past that level. And technology is slowly improving. There's lots of ways for it to improve. We can have better arithmetizations on the software side. We can have like FPGAs and ASICs for snarks. Someone might eventually like make a snarking USB dongle that you'd plug into your phone, and that'll kind of be the status quo for a few years. And then maybe eventually like Google and Samsung and all the cool guys are just gonna start including ZK snark chips into their phones. I don't know. So making like really improving efficiency and building more and better applications, right? Like one of the reasons why I kind of wanted to talk about snarks a lot is because snarks are one of the fields where you can still build something where there haven't been 25 copies of it already, right? Like people have built 25 versions of digital monkeys as ERC-721s, right? People have built 25 different stable coins, of which like half have blown up by now, right? People have built, 25 different blockchain-based Twitters where like every tweet just like goes completely on-chain. People have built, 25 different dog coins, right? And like 25 coins for each of the top 25 animals. But like stuff that uses snarks and kind of like really takes advantage of the technology to provide like these amazing combinations of privacy and scalability and security and other benefits. Like it's still a relatively new space, and I think it's one that's also worth building in, right? So that's stuff that I think is also worth thinking about. And at the same time, remember that like this is an ecosystem where technology is rapidly evolving. The stuff on privacy is, I think, closer to the application layer, and it's something that like each individual application developer definitely needs to think about. But snarks for scaling are this thing that the entire Ethereum community, I think, is pretty tightly coordinating around over the next 5 to 10 years, and this is going to have really amazing progress. And I think a lot of the technical issues that I talked about at the beginning that people still have after the merge, like those are exactly the things that all of our scaling efforts and a lot of our other efforts are kind of very directly targeting, right? So I think both the tools to build like really cool things on Ethereum and the base layer itself are going to be much more amazing in 5 years. And it's important to keep that in mind. And would be amazing to see more people here be part of the journey.
Thank you. Can you take a few questions? Okay. Yeah. So I think what we're going to do is we're going to have a few questions. So if you wouldn't mind, if you want to ask a question, if you could line up at one of these two big mics. While you're doing that, maybe if you don't mind, I'll ask one.
Sure.
So maybe this picks up on the identity point. I want to ask you about AI and crypto, which I know you're very interested in. So as you told us, you reminded us, we're undergoing a big explosion in the generation of content, thanks to large language models and other things. So, and this is open and democratized, right? So with stable diffusion, other technologies, we might expect that in just a few years, the majority of the world's content online might be produced by an AI, right? Whether it's text or pictures or videos, right? But that has some problems, right? So that can mean deep fakes, that can mean fraud, that can mean bots.
Yeah.
In other words, problems with identity.
Yes.
This is something that crypto is usually pretty good at solving, ENS, et cetera. So I wonder what your thoughts are. Do you think crypto might come to be a solution for some of these problems that AI might create? What do you think?
Yeah, it's definitely a very important issue, and it's even an important issue for a lot of applications, even within the crypto space, right? But like in general, I think it's definitely true that like the early internet has kind of lived off of this principle that you can just like look at someone's behavior and just like tell with enough attention on them whether they're a human or a bot. And that's something that's like rapidly moving toward not being true anymore, right? And then the question is like when you can't just like look at a piece of content to tell whether it's a true or fake anymore, then like what are the tools that we use to determine what things are true and what things are fake, and how do we preserve things like privacy at the same time, right? So I think there's a lot that you can do with just like plain cryptographic tools that are not blockchains, right? Like many more things should be cryptographically signed by default. Many more things should be cryptographically hashed into a blockchain by default. Like not just, I don't mean uploading everything onto the chain, but just like make a hash of the data and make a hash of all the hashes and stick that on chain. Like there are services that already do this and have been doing this for years, but just like create lots of pieces of proof that some particular thing was created by you and that it appeared at some particular point in time, right? Like the more of this extra information about every piece of media that gets created, then the better we'll be able to like determining which things are real and which things are fake, right? And I think it's like definitely important for things like journalism, right? And just like active reporting on live situations. one of the big reasons why I think, like tragically, we're still like definitely far from 100% on this, but like we're much better than 150 years is like extremely bad human rights infringements. Like they were on a totally other level 150 years ago, right? And I think one of the reasons why they've had to moderate is because, well, if you do stuff now, guess what? It gets photoed, it gets caught, and it gets pushed out on social media, and it's like a huge, massive PR cost for like basically, you and your entire regime, right? And like, if we go back to a world where sort of nothing is provable, then we definitely risk a pretty serious backslide, right? And we basically risk a scenario where like you can, if you do something really terrible to civilians, then you just like get a bunch of trolls to say, oh no, that's a deep fake, and you can you create. Even if people end up figuring out that it's true later, you create enough doubt that people are not able to coordinate around opposing that, right? And that's that's pretty bad. So I think it's definitely worth trying to figure out like how can we do a better job of having a better sort of info supply chain for, and like a verification supply chain for even things like pictures. And I think the ethos of crypto and blockchains, and especially sort of the ethos of decentralization is important here, right? Because like if you take the problem of like verify that stuff is true and you just give it to like a government or an enterprise person, their first instinct is going to be, we need a source of truth. What's a good source of truth? Well, we are, right? And the problem is that in this particular case, it's like, no, I think it's exactly like large governments and corporate abusers that we're trying to protect against in a lot of cases, right? And so a security model that depends on more diverse forms of trust, I think, is something that's important, right? So I think simple cryptography can be part of that. Blockchains are definitely good at the timestamping aspect of things, and then things like on-chain identity layers will just make it easier to say just like onboard us onto a system where everyone has some kind of cryptographic key. And so you do have like this easier evidence of like, oh, this was approved by this person because it was signed by this key. And guess what? You can go to the blockchain, you can check that this person's key actually did represent them at this particular point in time, right? So you can do all of those things, which, so that's all kind of outside of the crypto space. Inside of the crypto space, one of the interesting challenges that we're going to have is so proof of humanity, right? This project is trying to prove that which accounts correspond to which unique people, and this is just like one of the attempts to make a kind of less financialized and more democratic kind of backend for Ethereum applications, right? But the problem is that right now, proof of humanity basically relies on video evidence, right? Like to join the system, you have to submit a video of yourself, and this is like very accessible. It has this really nice benefit that it's like accessible to anyone. Like someone in Venezuela can do it, someone in China can do it, someone in Norway could do it, and it's all the same system. And someone off in some island in the middle of the Pacific where, for whatever reason, they're the only person on that island and they've been stuck there for 2 years, can still do it if they have a Starlink. So it's like as accessible as something internet-based can be, right? But the problem is that, in 5 years, this is not going to work anymore because deepfake videos are going to be too good, right? And so then the thing that we'll have to move to, I think proof of humanity will just have to move to being based on some kind of social network evidence, right? Like, oh, here is this some piece of information about who you are. Here's a couple of zero-knowledge proofs that show, what your local community is. Maybe here's like some popes of things that you've participated in, and like a bunch of evidence, and like the system somehow adjudicates and figures out, is this probably a human, or is this probably not a human or a duplicate or whatever, right? So we definitely have this like very short period of time, I think, within which we want to probably generate as much, basically kind of bootstrap these graphs as much as possible, right? Because the problem with social graph stuff is that it can be exclusive, right? Like if you're, somewhere in Western China and like no one else in Western China yet uses the system, well, guess what? You don't have a social, you're not connected to the social graph, and you're not going to be able to prove to it that you're a human, right? So this is like there's definitely, I think, this kind of urgency and its importance to think about this issue, right? Like basically, it's likely that the AIs that control the galaxy a million years from now are going to be bootstrapped based off of the values that humans express on the internet between the years 1995 and 2025. So, if that's true, then guess what? We have 3 years left. So, get the right content out there in a cryptographically secured form, get your values out there and basically do the stuff that still can be done so that when we have to switch to social network based stuff or kind of other less nice ways of distinguishing between the humans and bots, we'll at least have a lot more information to go off of.
Fascinating. Let's do one more. You want to go ahead? Yeah.
Testing. Is it on? Okay. Hi, my name is Tato. Vitalik, thank you for speaking to us tonight. And with everything that you've shared, I guess my question would be, how far do you think we are from having self-sovereign individuals in a financial sense of being able to transfer all your data and assets on chain, have them priced efficiently and get the ownership benefits thereof?
I think to some extent that exists already. The question is how big, what the level of inconvenience is, right? There are already people who basically, don't have bank accounts. They have their entire lives in crypto. They even manage to use crypto to pay for rent or even buy a house or whatever. There's even governments that accept crypto for tax payments in a couple of places. So it's possible, but it's hard, right? And I think it's not a binary question. It's like a sliding scale question of how much do you have to sacrifice to a kind of cryptoify or your life, or cryptoify your life is not even the right frame. It's more like the right frame is more get the benefits of this kind of digital self-sovereign or kind of self-issued or kind of sort of community based identity. And I think the way that we're going to get further along the spectrum, it just has to be based on network effects, right? It's basically exactly the thing that I said, right? If proving you're a human means proving your connections with other humans, and you're a human in Western China, and it just so happens that no one else is in Western China is on the system, then guess what? You're not connected to the network. You can't prove you're a human, right? And that's the thing that we want to avoid. And the more that we can kind of split the more that we can actually get network effects on the financial side, also on the identity side, and on the with things like proof of humanity, with things like popes, and just get more information out there, the more accessible this the benefits of this whole technology are going to be.
You do one more. Go ahead.
Hi, Vitalik. My name is Tim. I'm part of INSEAD, and before I ask my question, I just want to let everyone know that we do have a POAP for tonight. So there's a tablet at the registration desk. If you scan the QR and pass the human test, then you can get the POAP for today. Vitalik, I'm part of INSEAD. We are a non-financial application, and we struggle with building enterprise applications where we convert legal contracts into smart contracts. And one of the biggest problems, one example of what we run into in the limits of Ethereum every day and being a builder is that an enterprise user, for example, a startup, a DAO, a corporation even, in Web 2 SaaS software, enterprise software, it's very easy to have identity access and control, right? You have founder, you have a manager, you have an employee. If the employee is terminated, you can just remove them, and you remove all access. But as we are building enterprise apps, we really struggle with how to do that in terms of identity access control. Any thoughts on that?
Yeah, I think part of the answer is that I think Web3 is sort of a fundamentally different paradigm, right? In that the way that Web 2 sort of works, right, is that you have kind of often multiple sort of root identities, and then if you get say removed from a company, then your entire sort of identity at that company gets deleted, right? So if I'm like, Vitalik at Ethereum.org was actually the email I used to give out to people, but before it just like got so many spammers that like I can't even look at it if I wanted to. Like, if I were to be fired by the Ethereum Foundation, then Vitalik at Ethereum.org would just after some like I would lose access to it, and at some point soon it would just cease to exist, right? Whereas the Web3 approach is more like, oh, well, you have an identity and like it's self-sovereign and you always control your identity and it's always you, but you have these relationships and they're, you have like access and attestations and all these things, and like attestations can be added and they can be removed, right? So like that's it's a different paradigm, and I think like there's definitely some extent of sort of getting used to the paradigm, so that's part of it. The other part of it is that I think like enterprise identity often has a lot to do with access control of data, right? And so far, the crypto space has not really done much with access control of data, right? Like the crypto space, just the dominant way in which it's operated up until recently is like, oh, everything is on chain, and the only thing that we're doing is we're handling control of assets on chain, right? And like control of assets and control of data are somewhat different things, and I expect that's an area where the infrastructure on the crypto side is going to just like improve, because it'll have to start improving like once we start carrying or once like these privacy solutions really start evolving and becoming more mainstream. So yeah, hopefully that will make things easier over the next couple of years.
Thanks.
Great. I think we can take one more, maybe. Go ahead.
Okay. Well, thank you so much. I think it was a great discussion today, especially in relation to snarks. So I'm Sahina, and I'm working on a health tech startup with the most complex problem, which is health data, I would say. And so we're using zero knowledge, obviously, encryption today. But snark seems to be a very interesting choice potentially for us to explore. So I wanted to understand like what projects are currently happening now in the DeSci space that are already using snarks that would be worth noting.
Question. So like over the years, I definitely, a couple of times a year, always end up talking to people that try to do some kind of like ZK data marketplaces. I think so far they haven't been super successful for a couple of reasons, right? Like one of the, like there's just like technology maturity. Another one is that I think there is like this direction of like doing machine learning on data while keeping the data private. And like this was a dream of cryptographers, but like that dream ended up not really working out well for two reasons. Like one of the reasons is that the overhead of ZK is just too high. And the other reason is that like the way that AI is going, it's like, it just looks like, if you just like add even more transformers, like you end up not needing as much data. And like data is just like, this is just from my conversations with AI people. It feels like data is a bottleneck, much less than data was a bottleneck 5 years ago, right? And so the whole, labor as data stuff and like getting people compensated for the data and like those kinds of issues are like, it just looks like they've become less important because like, well, even if that becomes becomes what the world looks like, then like what would every AI project do? Like they would just you stick to using only the subset of data that doesn't have any encumbrances on it, and then that will, and that's just going to be enough for them, right? So the thing that I think actually makes sense is like the personalized medicine direction, right? Of like, you have data about yourself, and you want to use like some algorithms to figure out like which particular treatments work well for you, and then you want to do that without revealing your data, and there is. I think for that, like zero knowledge or like ZK snarks may not be the right technology, like maybe either fully homomorphic encryption or garbled circuits or like MPC or something in that direction probably is. And like, there are projects that are quietly working on this. I think so far, like, yeah, they just hit the kinds of snags that they tend to hit is like either, they try to solve the wrong problem or just like it's a space where it just like, obviously harder to do stuff in general, but also harder to like it's less flashy than like the digital monkeys, and like we're not in a bull market anymore, so the digital monkeys are crashing. So maybe now is actually the time to do this sort of stuff. So I definitely wish all those projects the best.
Thank you.
Well, Vitalik, thank you very much. I think we have one more part of the program. All right. Important part of the program is pictures, of course. We have to
Yes.
prove that we're humans.
Indeed, yeah.
We only have 3 more years. So.
Mhm. Yes, I do.
Another talk later? Great.
Come. Just come. Just come.
Okay.
Come. Okay. Oh, okay.
Thank you so much.
I think they reverse us.
Oh, I see. Okay,
Yes.
perfect. Oh, yeah, it's a great idea.